All right, so we're going to start chapter 2. And chapter 2 is all about polynomials and rational functions. So very exciting stuff. Polynomials. Now, polynomials are going to show up a lot of places in your future. If you plan on taking calculus next year, you do a lot of polynomials in calculus. Polynomials are just beautiful. They're continuous, they're flowing, they're just nice graphs. We're also going to do rational functions, which aren't as nice, but those are the ones that have the asymptotes in them and stuff. We did a little bit of that last chapter. So rational functions. You will need your calculator. By the way, I did have someone leave their calculator in here after the test. Does anyone know that they do not have theirs? Or it might not have been this class, it might have been my other class. But all of you guys have your calculator? You're missing yours? So 2.1, all of it today. And we're going to focus on polynomials. Polynomials. We're really going to focus mostly on linear functions, linear polynomials, and quadratic polynomials. Okay, first of all, what is a polynomial? Do you know what poly means? Many. Yeah, poly means many nomials. It's like Polly's pies, many pies. Just kidding. I used to work there. Okay, so here's what a polynomial is. Okay, letter A. We'll do a little intro. F of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0. That's a polynomial. That's like, okay, now, it looks pretty bad, huh?
Can you, do that again?
No.
What's the dot?
Oh, that's all. It could be longer in the middle. It could be shorter. It just means there might be some stuff in there. Okay?
It looks better with numbers.
Now, here's the thing. A sub n, these are the coefficients. A sub n minus 1, a sub 2, a sub 1, a sub 0. All of those, all of the a sub n's, these are real numbers. Real numbers. Okay? And n, the exponent, has to be a non-negative integer. Let's just say it has to be a natural number. A natural number or a counting number. So 1, 2, 3, 4, all the way up. Okay? No fractions, no negatives, not 0. All right? So that's the definition of what a polynomial is. Now, you know what polynomials are. You could probably recognize them. So here are some examples of polynomials. F of x equals x to the 5th minus 4x squared plus 10. Okay, that's a polynomial. You did a whole chapter on polynomial last year in Algebra 2. You learned about how many terms it has. You learned about the degree of it. Okay, how many terms does this one have? 3. So it's called a trinomial. It's a trinomial. It has 3 terms. What degree is it? It's degree 5. Do you remember what a 5th degree polynomial is? Starts with a Q. Quintic. Good. Quintic. Someone, look at your face. Like, how did you remember that? That was totally that face, huh? I know. Yeah. When I was young, they used to have this little toy that came out, and it was called the quints, and it was like these little babies, and there were 5 of them. It's like the quintuplets. Like like the Octomom type of thing. All right. Anyways, so here's what type of question you will get, maybe in your homework or quiz or something. It'll say, is it a polynomial? Yes or no. And then they might ask you why. Is it a polynomial? Yes or no. So let's do a few. Here we go. Letter A. F of x equals 6x to the negative 4 plus x squared minus 10. All right, is that a polynomial? Yes or no, and then why? No, it's not. It's not because of the simple reason right here. Cannot have a negative exponent. Okay? You'd write that out. No negative exponents allowed. All right, how about this one? H of x is equal to the square root of 7x plus 3. Is that a polynomial? No, it's not a polynomial. See, the polynomials, this is the same thing as 7x plus 3 to the 1/2. And remember, polynomials, their powers have to be natural numbers, counting numbers. 1, 2, 3, 4, 5, 6, all the way up. All right, how about this last one? G of x is equal to, oh, I should probably write no next to it. 4x cubed plus 2x squared minus 3x plus 1/2. Yes, that is a polynomial. I tried to mess with you there. Do you see what I tried to do? I put a fraction in thinking I would fool some of you, but I didn't. You guys are too smart. I'll probably trick 5th period, though.
Yeah.
That's so rude. Sorry if anyone's listening in 5th period. Okay. Right? That's okay. It's okay. All right, so this would be yes, this is a polynomial. Looks like a polynomial. It's great. Perfect. Okay, oh, by the way, do you remember what the leading coefficient of a polynomial is? Leading coefficient? Let's write that down. The leading coefficient, I'll abbreviate, is the number that leads the whole thing when it's in standard form. Standard form is descending order of exponents, 3, 2, 1, 0. So the leading coefficient of that polynomial would be 4. They might ask you that. Okay, so that's just introduction to polynomials. Let's go ahead and we're going to focus on 2 types today. We're going to focus on linear functions. We've already done some lines, right? Chapter P, right? We did equations of lines. Did we do slope, intercept, and all that stuff? Yeah. Okay, good. All right, so when we do these linear functions, our linear function, sometimes they'll write it like this. F of x equals ax plus b. Okay, that's a polynomial. Linear functions are polynomials. But most of the time, they like to just write y equals mx plus b. M is the slope. Okay. M is the change in y over the change in x. That's a triangle. Do you know what letter that is in the Greek language? Delta. Yeah. Did we talk about that already? Yeah. Delta y over delta x. The change in y over the change in x. It's the rate of change. Okay, so let's just do a couple nice, easier warm-up problems. Here we go. Number 2. It says here that we need to find the equation of the line in slope-intercept form. Y equals mx plus b. And we're given 2 pieces of information. We're told that f of 2 is -4, and f of -3 is 7. And we have to find the equation of the line. Now, that might look really strange to some of you. Like on that test, when you had to evaluate f of 1, people were pretty mad at me about that one. Yeah. All it is telling me, you're plugging in an x value, and this is the y value that goes with it. You just had to go to the graph, go to 1 on x, and find out what y was. Okay, so this right here is the point to -4. And this is the point, what? -3, 7. Okay, so we have 2 points, and we have to find the equation of the line. Yeah, so our first step is to find the slope. We're going to go 7 minus -4 over -3 minus 2, which is what? 11 over, ew, really? -5? Did I do that right? Do you always get confused, like, okay, are you sure? Because it came out to be a really ugly number, but yeah, looks right to me. Okay, so now I'm going to pick a point. It doesn't matter which point. I'm just going to choose the first one, and I'm going to put this into point slope form. So we'll go y plus 4 equals -11/5 x minus 2. Okay. Let me see. Does your book have you do this? Looks like it. Yeah. And now let's go ahead and distribute. So y plus 4 equals negative 11/5 x plus 22/5. Okay. And we'll subtract 4 over to the other side. And subtracting 4 is the same thing as subtracting 20 over 5. So I want to get a common denominator so I can subtract my fractions here. So I get y equals negative 11/5 x plus 2/5. And there it is. Not the prettiest of things, but it works, right? We're good. Okay, so you've done this before. You don't feel all that like scared to do those. Those are okay. All right, now let's do, we've already done that too. We've already done a word problem. Let's do scatter plots on our calculator. So that's why I wanted you to bring your calculator in today. We're going to find a regression, a linear regression. And a lot of you guys have done this before, especially if you were here last year. In Algebra 2, we did this. I just finished it up this week in my Algebra 2 classes. I don't know if some of you guys are tutoring kids, but we just did linear regression, and we're going to do it in here. We're going to do linear regression today, and we're going to do quadratic regression in a little bit, okay? So grab your calculators, get them out. Everyone's got to have one. And what we're going to do is we're going to do some scatter plots. And those of you who are also in AP Stats, you're going to do some of this year too. Have you done it already? Scatter plots yet? No? Oh, you're going to be great at it. All right, so the scatter plots that we're going to focus on are going to be linear. Okay? What we're going to do is we're going to have some data, and we're going to plot it on our calculator. And what's going to happen is we're going to get something that looks like that. And so our dots are all going to go in a line. Okay, not a perfect line usually, but some kind of a line. And this right here would be a positive linear association. Okay, there's a positive linear association between your data points in column A and column B. You could also have something like this. Okay, and those are going in a negative linear association. Negative linear. Now, in order to tell how good our line is, because some lines are going to be better than others, okay? If my dots are kind of spread out more, my line's not as good. It's not going to represent all the data points. We go to something called the correlation coefficient. And if your stat diagnostics on your calculator have been turned on, which I hope they have been, if not, I can help you, the correlation coefficient is the letter R for lines. It's R squared for other things, but right now it's R. Now, the closer that R is to plus or minus 1, so positive 1 for a positive linear association, negative 1 for a negative linear association. The closer R is to plus or minus 1, the better fit the line is. The better fit of line. Okay, so let's go ahead and do one now. We're on number 3. And I'm going to give you some data points, okay? So here we go. Now, a store is selling cereal. Real life problem here. They're selling cereal in their stores, and basically they have a list of how much they're selling this cereal for, okay? So they have cereal, the price of the cereal, and the amount of boxes that they sold, okay? This is for maybe for like a week or something, maybe a month, I don't know. So for 1 month or 1 week, they were selling the cereal for $2.40. And they sold 38,320 boxes that week. That's a good price on that cereal, I guess. But then they thought, nah, the sale's over. Let's up it. So at $2.60, 33,710 boxes were sold. Okay? All right, 280 was 28,280. Then it went up to $3. And at $3, they sold 26,550 boxes. 320 was 25,530 boxes. Two more. $3.40. Wow, it's gone up a whole dollar since we started. 22,000 boxes, 22,170 boxes were sold. And finally, at $3.60, that's the highest it went, they only sold 18,260 boxes. Okay? And this should make sense in real life, right? People see the price of that, $3.60, and 20,000 people decided not to buy that cereal anymore. So what we're going to do is we're going to do a couple of things here. Actually, more than a couple. Letter A is we're going to draw a scatter plot on our calculator, which we are then going to put on our paper. And we're going to include the window, okay? So that's the first part. And then we're going to find the equation. We're going to do a whole bunch of stuff, okay? So here we go. If you have never done this before, who's never done this before on their calculator? Who just got the yeah? Okay, so you really need to pay attention. Here we go. It's okay. You're not in trouble. It's all right. All right, so we're going to go to STAT. STAT stands for statistics, okay, STAT. And we want to choose edit. We want to edit our list, so hit enter. Now you should have L1 and L2. If you have data points in there, because maybe you lent your calculator to your brother or something, right? And you probably have stuff in there or whatever. So go up to L1 and clear your list. Don't delete them. If you delete your list, you delete it off your calculator. I can fix it, but you delete it. So you want to clear, enter. Go to L2, clear, enter. So we all should have L1, L2. We're all good, ready to go? No?
We do explain afterwards. I'm missing like L2, 3, and 4.
You are? Yeah, hold on. Okay, so for L1, I'm going to type in the prices of the cereal. So $2.40, enter, so on and so forth, all right? So do that with me. Okay. And then arrow over to L2, and then enter all of those numbers. They're pretty big. We don't have that many, though. We did this last year with predicting Olympics. Did you guys do that at all? We're predicting like what the next race was, the time for the next race was, stuff like that. All right, your L1 amount of data points should always match up with your L2. If you accidentally put one more in than the other one, then it's not going to graph it. It won't be able to because it's not matching up with anything. Okay, so we're all there? Now go to y equals. And if you have anything there, clear it. And you need to turn your plots on. My plots are turned on. To turn your plots on, you just arrow up to it. Right now they're turned off because it's not dark. So go up to it, hit enter, come back down, they're turned on. Okay. Now, if I went to just hit graph, they wouldn't show up, because the window I was using earlier is not going to match the window I'm doing now. I was doing ice cream sales or something, and it was only like 200 ice creams were sold at some class carnival thing. So I need to get a different window here. Every single time I put in new data, you need a new window. And the best thing to do is to hit zoom number 9. Let me show you what zoom 9 is. Hit zoom, and if you scroll all the way down to 9, it's zoom stat. It's zoom for your stats. Do you like that? You didn't know about that one last year?
No, I made a mistake.
Oh, zoom stat. Oh, there they are. Okay, now, you can tell if you made a mistake because you might have a dot that's way off. Okay, let me show you what that looks like. What if instead of $3, I put in $33 for a box of cereal, right? And when I hit zoom 9, look at that.
I'm having a problem. Oh, I fixed it.
Yeah?
What goes in Y1 and Y2? Or like Y1?
so you get something that's very linear, right? That looks pretty linear. Almost looks cubic, but that's okay. So let's go ahead, and what we're going to do is you're going to now plot your points, okay? And they don't have to be perfect. Just sketch it the best way you see it. That's about what mine look like. I do need to know what your X's and Y's are, though, because this could be for anything, right? So go to Window. Hit the Window button. When you hit the Window button, mine says that X goes from $2.28 to $3.72. And my Y, the minimum is about 14,800 all the way up to about 42,000. You can round. Rounding's fine. I don't mind that at all. All right, so that's the first part. Draw a scatter plot, include the window. Now letter B. Let's find an equation that models this. Let's find an equation for the line of best fit. It's also called the trend line. The trend line, line of best fit. So here's how you find that. You go back to Stat, and you want to calculate the line. So you're going to go over to Calc, and you're going to press number 4. Number 4 is lin reg. Y equals AX plus B. Number 4. Hit Enter, Enter. Okay, and we're going to round to, I don't know, 2 decimal places. So our line of best fit is Y equals negative 15,358.93 X plus, it's pretty gross, right? 73622.5. So there's our line of best fit. And let's go ahead and put that line on our calculator now. Sorry, I covered it up. There's 2 ways to put this into your calculator. Go to Y equals, and you can manually type it in, right? You've done that before? Manually type it in. Or there's a fancy way. Do you remember the fancy way? No? Let me teach you. So go to Y equals. Everyone's here. It's blank. It's flashing. Go to vars. You see where vars is at? It's right here. Vars, variables. And look at the list. What are we doing on this list? We're doing statistics, number 5. And I look up here and I see EQ, which stands for equation. Number 1 is the regression equation. So any regression that I'm doing, if it's linear, quadratic, cubic, logarithmic regressions, there's sinusoidal regressions, that'll give you the regression equation. Hit Enter, and it'll put it in for you. Now press graph. Ooh, so good. Didn't do it?
No, I feel like it was me.
Your calculator does not hate you. It's incapable of hating. There you go. And there's your line. Okay, by the way, is this a pretty strong line? Yeah? If you go back to Stat, calculate the regression, you get an R value, I should have written this down earlier, but I forgot, of negative 0.98. Would you be happy if you got a 98% on your next test? Not some of you who got 102, but some of you would be happy, right? Yes, someone got 102.
Mine didn't give the R.
Okay, so the R's turned off. So let's go ahead. I'm going to pause this. So let's say that we raise the price to $4 per box. So how many boxes will we sell now? You find that answer whichever way you like to find it. You want to plug it in, or you want to go to the graph and hit trace. You will have to change your window, though, if you do that. I'm going to do it that way. How's it going? Pretty good? All right. How many did you get? I did trace on my calculator. How many of you guys did trace on that line? Yeah, you like it that way? And I got 12,187 boxes. Yeah? Okay. You can also do it by plugging in too. Okay, so that's linear regression. Now let's go ahead, and what we're going to do in part C is we're going to do some quadratics. Quadratic. And we've got quite a few of these. Okay, so let's go back to this. We're going to stick with the serial problem right now. Okay. So number, what are we on? 3? 4? Number 3, maybe? 4, sorry. Number 4. Okay, so we have the equation y equals negative 15,358 point, what was it? 0.93x plus 73,622.5. All right, so that was the equation telling us when x is the amount of cereal, that's how many boxes you're going to get, okay? So what I'm going to do is we're going to make this into a quadratic function. Let me find out where this is. Here it is. Okay. So we're going to develop a model for the weekly revenue for these breakfast cereal boxes. We're going to determine the maximum revenue and how to achieve it. All right, so here we go. To develop a revenue, they'll call it R of X for revenue. Basically, this is what's happening. You're selling boxes at a very cheap price, and a lot of people are buying them, right? Which is great, but are you making that much money? Then if you raise the prices too much, not that many people are buying them anymore, are you making a lot of money there? No, probably not. We have to find kind of the middle ground of where we're going to make the most money and what price we want to sell the boxes at. That the most amount of people are going to buy for the most amount of money that they'll buy it at, okay? All right, so to do that, this is what you want to do. You want to take X, the price, times Y, your function that's given to you, okay? So the revenue function is going to be this. R of X equals negative 15,358.93x squared plus 73,622.5x. So you take the price of the X, the price of the box, times how many that you're going to sell, which is Y, and that's going to be our revenue. Now this is a negative parabola, okay? A negative parabola is going to look like this, right? And it's going to have a maximum, which is its vertex. And we're going to find that on our calculator, okay? So go to your calculator, and we're going to plug this in. So go to y equals. We're not dealing with our plots anymore. We're still dealing with the same question, but we got our equation that we needed, and now we're going to find the revenue. So turn your plots off, and let's plug in this equation. Negative 15358. I'm wondering if, all right, we need to change our window. Our window's not good right now. What window should we use? Let's go, X is still the price of the box of the cereal. So let's go like $0 to $5. And revenue is how much they're going to make from these. Not Y is no longer, you know, how many boxes are being sold. It's going to be the revenue. I don't know. I might need to tell you that. But let's just go 0 to, I don't know, 200,000. Let's try that. 0 to 200,000. That might be too much. It's a little bit overkill. We could go back and change our window if you don't like that to like maybe 150,000. Okay, you might have to mess with it a little bit until you get the right window, but there it is. There's our equation of our parabola, and we want to find the maximum amount, like what we should charge our cereal boxes to get the most amount of money for them, okay? So we're going to calculate the maximum. You did this last chapter, right? Second trace, which is calculate. Calculate the maximum, and then go to the left and right. Left, bound, right bound, enter. And it says that we should charge $2.3967. So we should charge $2.40 per box, and we will make a revenue of $88,226.73. That's the vertex right there. Pretty cool, huh? Now, this is used like in economics and stuff like that. You do all kinds of stuff. All right, so that's a quadratic function as an application. Now we're going to do quadratic functions using their graph and their vertex form, all that stuff, okay? All right, so let's continue. All right, so let's talk about quadratics now, okay? Quadratics are a polynomial, and there are two different ways to write a quadratic. So, part D. Forms of quadratics. Okay. And this is all review from last year, but we took our time on this stuff. We did this in like a week or something. This is, one class period, so it's a lot. All right, so there are two forms. You can either have standard form or vertex form. And let's talk about each of these. Standard and vertex. All right, standard form is y equals ax squared plus bx plus c. It's a standard form of a parabola, a quadratic function. You have a U-shaped parabola right here. Okay. This right here, the maximum or minimum of it is called the vertex. And there is an axis of symmetry that goes straight down through the vertex. Okay? Now, to find this axis of symmetry, you would do x equals, when it's in standard form, you do negative b over, does anyone know? 2a. Yeah. Wow, you remembered that. That's really good. You do x equals negative b over 2a. Thanks. Joanne?
I think it's for Lucas.
Lucas. Oh, is your mom, where's Lucas? Where are you? Is your mom Joanne?
Yeah.
Oh, okay. Sorry, I didn't mean to call you Joanne, Lucas. That's for your mom. Are you going to open it? Yeah? You're tempted. Oh, that's mail fraud. No, just kidding. It's probably money, right? You say, oh, I never got that. No. What are you talking about, Mom? No, don't do that. Don't do that. Okay. I was recording. Okay, all right. So this is x equals negative b over 2a. Now, to find the vertex, you would do the x coordinate of the vertex is negative b over 2a. And do you remember how to find the y coordinate? You plug it in. You plug that x in, you would do f of negative b over 2a. Yeah, and that's how you do that. And you guys did that last year. You did, in Algebra 2. I know you did. All right, over here, vertex form, which I prefer, personally, would be y equals a. By the way, those are the same a in both here and here, okay? Parentheses, x minus h squared plus k. All right, so it's the same thing. Here's your parabola. It's a really gross one. Here's your vertex with an axis of symmetry. Your vertex is at hk, and your axis of symmetry is x equals h. Okay. That a, that's the same on both of them. If a is greater than 0, our parabola will open up. And if a is negative, everything gets flipped over the x-axis and it will open down, which you guys should know already. Okay, so here we go. We're going to do some problems involving quadratics. So, number 5. All right, so suppose that we have f of x equals 3x squared plus 12x plus 11. Okay, and we're going to find the vertex. Find the vertex. We're also going to find the axis. They call it the axis. You're probably used to axis of symmetry. It's the same thing. You're going to find the axis and the vertex. And we're going to write this in vertex form. So we're going to go from standard form to vertex form. Okay, so we're going to find both of those things and then rewrite it. Now, there's 3 ways to do this. Number 1, you can graph it on your calculator and find the maximum or minimum depending on if it's opening up or down. That's your vertex. The other way is to do x is negative b over 2a, so you have to memorize the formula. The other way is you could complete the square. You've already done that this year. What do you want to do? All of them? Do we have time? No, no one wants to do all of them. Let's do the old algebra 2 way, which is to do x equals negative b over 2a. Okay? So x equals negative 12 over 2 times 3. And that gives us negative 2. So that would be our x value. Take negative 2 and plug it in. Do you need your calculator for that, or probably not, huh? Well, I don't want to make a mistake. Do you use your calculator on things you probably shouldn't, just so you know that you're right? 1 plus 4? Yeah. Maybe not that bad, but I got negative 1. Yeah, anyone want to check my work? Negative 1. Okay, so there it is. There's the vertex. The axis is going to be x equals negative 2. Remember, the axis, we're doing parabolas that open up or down. The axis is a vertical line. If you forget the x equals part, I'm going to mark you wrong. Because if you say negative 2, I don't know what that is. Like, what if I gave you a paper and I said, okay, we're having a quiz today. Graph negative 2. You would look at me like I was crazy. You can't graph negative 2. Now, if I tell you graph x equals negative 2, you'd graph a vertical line. Okay. So now, let's go ahead and rewrite this in vertex form. F of x equals a. What's a in this problem? 3. Yes, it's the same one here. Same a. Okay, standard form and vertex form, same number. 3x plus 2 squared minus 1. And there it is, vertex form. Now, I let you choose. The book might say, use complete the square. Why would I want to complete the square when I can do it this way, right? So I let you guys choose, okay? If it says to complete the square and you want to, knock yourself out. Go ahead. But you don't have to. You can do it this way. All right, number 6. Suppose now that I'm given the vertex of a parabola, of a quadratic function, is negative 3, 5, and a point on my graph is 2, 12. Okay? All right, so I'm given the vertex is negative 3, 5, and a point on the graph is 2, 12. Now the vertex, this is a special x and y point on our graph. This is h and k. And you can take those and you can plug them into vertex form. Okay? So let's start with that. Y equals, I don't know what a is yet. I don't know. I mean, I could probably plot it and try and figure it out, but I don't know what it is yet. I do know that h is negative 3 and k is positive 5. So this is going to be x plus 3. Don't forget the squared. People make a mistake on this problem, that's usually it. And then plus 5. All right. So now I need to find out what a is to get this to be exactly correct. I know the vertex, I plugged it in. This over here, this is a point on my graph. This is an xy coordinate. So I'm going to take x and 2 and plug it in for x, and 12 and plug it in for y, and solve for a. Okay? Let's do it. So 12 equals a. 2 plus 3 squared plus 5. So I'll subtract 5 right away. 7 equals a times 25. 3 plus 2 is 5. 5 squared is 25. So a equals 7 over 25. I don't think I would have been able to figure that out from the graph. That would have been really bad. All right, so my equation would be y equals 7 over 25 x plus 3 squared plus 5. And that's it. You did that last year. Do you remember that at all? Do you remember doing that? Yeah? Some of you are like, mm-hmm. On the video, no, some people were shaking their head, yes. Okay, here we go. Because you know people are listening, like no one knows what's going on. Now, let's do one that we have to come up with ourselves. These are a little bit harder, okay? Suppose that you have a rectangle. This is exciting. And the perimeter of that rectangle is 30 feet. No, let's go 60, sorry, 60 feet. Perimeter is 60 feet. Now we want to find the dimensions of this rectangle. There's an infinite amount of rectangles, right, that you can come up with that has a perimeter of 60 feet. We want to find the one and only that gives us the maximum area. Find the dimensions to give the maximum area. It's a very, kind of like a famous problem. Like you have enough rope to rope off your cattle, right? This is very relevant to your lives. But you want to get the most amount of area for them, okay? So you have to figure that out when you have cattle next year. Okay, maybe you have a garden, you know, and you're trying to get the best. We have wire to keep the chickens out or the bunnies or whatever. Okay, here we go. So draw yourself a rectangle. And let's call this side X and this side Y. I don't want two variables, but right now I'm going to have two variables. Okay, and I know that 2x plus 2y equals 60. That's the perimeter all the way around. Okay, so let's solve for y so that I can solve for y in terms of x and just have one variable. So subtract 2x to the other side. Divide everybody by 2. So y equals negative x plus 30. All right, so I'm going to redraw my rectangle. My rectangle is now x by 30 minus x. Does that make sense to you? I just substituted it in. And I want to maximize the area of this thing. The area of my rectangle right here is what? What's the area of that? X times 30 minus x. This is a lot like that cereal one we just did a little bit ago, where I had to do the revenue was x times the y. It's the same thing. Okay, so, but what I get now is I get a parabola, right? Distribute that x, and you get negative x squared plus 30x. Not only is it a parabola, but it's a parabola that is upside down. So it's going to have a maximum. It's very exciting. Does anyone know what it's going to be already? Anyone ever done this problem before? No? Okay. It's exciting then for you. All right, so go to your calculator. And we're going to plot negative x squared. You know, you could also do a negative b over 2a if you wanted to. But we'll just graph it. Negative x squared plus 30x. We need to change the window. So x would be from, I don't know, we'll say 0 to 30, and y would be 0 to, no, it didn't work. Y has to be bigger than that. How about x is 0 to 30 and y is 0 to 100? Nope, still not good. Okay, make it bigger. How about 200? Aha, nope, still not good. Do you ever do this? This is fine. This is good. Let's make it 300 now. Okay, finally. All right, so I got that, and I want to find the maximum. No, you didn't get that? Calculate number 4, maximum. Enter. Enter, enter. Oh, look at that. X equals 15 feet. Now, what was the question? Find the dimensions to give the maximum area. So now I need to find out what the other side is. of this rectangle, what is it? 15. It's a square. It's a square. The square makes the largest area. Isn't that really cool? Is anyone like super excited about that besides me? No. Okay. All right. It's a 15 by 15 pen that you have to make for your little chattels, your candles. All right. Pretty good? Are you about to fall out of your chair from the excitement of this class today? No? Are you done? We're not done, though. I'm sorry. One more. That's it. Just one more. And then you can leave. Just kidding. Okay, last part, and I've saved the last for the worst. The worst for the worst. Now, we've talked about velocity already in here a little bit. Remember, like a rocket shooting up or something from the ground? Okay. So we want to talk about vertical free fall motion. Last part. Is this part E for reals?
Mm-hmm.
Sorry. Vertical free fall motion. This is for all you physics people out there. Who's in physics? Ooh, a lot of you. Do you talk about velocity and gravity and all that cool stuff? Yeah. I wish I would have taken physics. Okay, it says here that S of t is equal to -1/2 gt squared plus v sub 0 t plus s sub 0. Okay? And let's talk about what all this stuff means. We know what this stuff means, right? Some of us do. We know it from like the other chapter when we did this. What was v sub 0? Do you remember what that was? Starts with an I. Good. Initial velocity. That's the starting velocity. S sub 0 is the initial height. Okay. G is going to be one of two things. G is actually an approximation, depending on if you're in America or if you're in China doing this problem, right? G is 32 feet per second squared, or G is, do you know the meters? 9.8 meters per second squared. That's what G is. And G is the acceleration due to gravity. T is time in seconds. T is time in seconds. And S of t is going to be, S is the height. Okay. And then we also have a velocity equation. V of t is equal to, here's your velocity equation, -gt plus v sub 0. So you have two equations in this problem. You have a height equation and you have a velocity equation. And actually the velocity equation comes from the derivative of height, which I don't know if you know that. Do you know that? No? Oh, you're going to one day. You're going to be very excited about it too. Okay, now what they've done is they gave you, so last question. Whoa, that's all we've learned today. That's it. Okay, last question. We're on number 8. What they've done is they've given you a whole table of values again that you have to punch into your calculator. Okay, what they've done is they've taken a rubber ball from a CBR reader thing. Have you ever done one of those? No? It's kind of fun. All right, so what they did was they did a second and the height of this rubber ball. Okay? And they put it into a scatter plot and they came up with this equation. I'm going to skip that part and I'm going to go ahead and write the equation for you. All right, so the equation is equal to, right here, S of t equals -4.676 t squared plus 3.758 t plus 1.045. Okay? And they tell you that the height was measured in meters. The height is in meters. Okay. And their R squared, whenever you do linear, you look at the R value. But if you're doing a quadratic regression, the R squared was 0.9999. Very excellent fit. Okay? All right, so the question's going to be this. Use the model to predict the maximum height of the ball and its vertical velocity when it hits the face of the CBR. Okay? So it says right here that they use a calculator-based ranger, that's called a CBR, and a 15-centimeter rubber air-filled ball, and it was placed on the floor. The CBR is placed on the floor, okay, and the ball was thrown upward, and it came back down and hit it. That's what's going on here. So basically, you're taking this, and you're throwing a ball, and it's hitting the ground. And then the CBR is on the ground here, and it's measuring all that stuff. It's actually really cool. I wish I had one. And then they came up with all the data points, and they put it in their calculator, and it outshot that equation. All right, so what they want to do is they want to find the maximum height. So letter A, what is the maximum height that the ball reached? Okay, maximum height is going to be your vertex. So you go to your calculator, and let's plug this whole thing in. So negative 4.676 x squared plus 3.758x plus 1.045. Change the window again. This was from like 0, they did it in 0 to 1 seconds. Okay? So go 0 to 1. And the maximum height in the table shows it as 1.8. So let's go 0 to 2 and try that. Ooh, that was really good. So if you didn't hear that, the window is from 0 to 1. It's very quick. Rubber ball, super quick, 1 second. Okay? And the height is 0 to 2. So you graph it, and there it is. All right, so let's go ahead and calculate the maximum. So we'll hit enter, enter, enter. Calculate the maximum, and you get the maximum height was 1.800000 meters. And it happened at 0.40 seconds. Okay. You find that by using calculate the maximum on your calculator. All right, the other question is, and this is the harder one. It says, use the model to predict the vertical velocity when it hits the face of the CBR. Okay. How fast was it going when it hit the ground, basically, is what they want to know. And you use the velocity equation for that, the velocity equation. Okay. Now, the way that you find the velocity equation, if you know calculus, it's an actually easy way to do it. But we have to do it our way, which you don't know calculus. You can't find the derivative of that yet. Okay, so let's go ahead and we have to find out, well, we know what G is. This is in meters, so G is 9.8. Okay, 9.8. Negative 4.676 is equal to this number in front of the t squared. If you look at your first equation I gave you, is negative 1/2 g. Okay? So this is equal to negative 1/2 g. So we already know. We already know that, though. It's 9.8. You multiply that, you get about 9.8. Okay? So we could just put that right in. We don't even need that, huh? All right, so V of t is equal to, because the book had you actually find it, but if you know the meters, well, it's actually not 9.8. It's going to be less than that. I hate this part. All right, negative 4.676 times negative 2 gives us 9.352. 9.352. Should be about 9.8, but it's a little off. 9.8 is when you're at sea level. Maybe this happened somewhere else. I don't know. So, all right, plus the V sub 0. V sub 0 up here is 3.758. Oh, that's a T. 3.758. Okay, so there's the equation that we need to get us to the next answer for the question they're asking us. So the question is, what is the velocity when it hits the ground? Okay, well, when does it hit the ground? We have to find out that. And that is found when you go to your calculator. Go to, I'm going to change my window a little bit just so I can see a little bit more. I have to find out right there. Do you see that? Where it hits the ground. So I can go to y2 and put in y2 equals 0, which I would need to probably change my minimum a little bit too. And I will find the intersection. Some of you guys like to find the 0. I'd rather find the intersection. So calculate number 5, and I get that. The time is 1.022 seconds. That's how long it takes for it to hit the ground. So now I have to take that t and plug it into there, into the velocity equation. So v of 1.022 equals 9.352 times 1.022 plus 3.758. 13. Make sure. No, that's not even right. Oh, it's negative. Dang it. Sorry, guys. Negative. Let me just insert a negative there. Seems like it can't be positive. It's going down, right? Negative 5.79, negative 5.8. Negative 5.8, we're in meters per second. Okay? So, let's talk about this real quick. Here's this rubber ball. Someone's throwing it up into the air at an initial velocity of, they gave that to us, what was it? The initial velocity was 3.758 meters per second, okay? It goes up, the velocity at the very top. Do you know what the velocity at the top is? 0. There's no speed at all. Velocity is like speed, but it can be negative. So it gets to the top, and it's just like that hang time there. So there's nothing, and it's coming back down, and it's getting faster and faster as it comes back down to the ground. And when it hits the ground, it hits at negative 5.8 meters per second.